This video I wanted to talk about the periodic table and electron configuration a little bit. And so I just want to reiterate here that in this column here, column 1A, all of these elements will have an electron configuration that ends in something S1. So for example, hydrogen, you can see here, ends in 1s1. Lithium ends in 2s1. Sodium in 3s1. Potassium 4s1, so on and so forth. And you can see that the row tells you the energy level, that highest energy level that it will be. So we know for example, cesium is in row 1, 2, 3, 4, 5, 6, which means it's going to end in 6 something. It's in this first column here, which happens to be S1, so it'll end in 6 S1. And for column 2A, things end in S2. And that makes sense because we have lithium here, which is 2s1. If we add in one more electron, it'll be 2s2, right? Sodium ends in 3s1 if we add one more electron. So if we become magnesium, so we add a proton and an electron, it becomes 3s2. So then all of these in this column will end in s2, with again the row showing you what s2. So if I do potassium, it's in row 1, 2, 3, 4. If I go to this second column, that's S2, so it'll end in 4s2. 4s2. Now if I skip over all of these guys and go over here, you will start to have things end in P1 here for boron. So let's do that one first. So boron is in the second row. It's in this first column over here, 3A, and this is where it starts with P, right? Again, if we go lithium, 2s1, beryllium, 2s2, one more electron gives us 2p1, so then all of the elements in this column end in something p1, and again, that's governed by the row. So if we go down here to the fourth row, for gallium, gallium will end in 4p1. Which means the next column over here will end in P2. So carbon will be in 2p2, silicon 3p2, so on and so forth. Germanium 4p2. The next column here, they'll all end in P3. Again, just because you're adding one more electron. So there you go, arsenic goes to 4p3, and all of these will end in P3. This column will end in P4, so if we take tellurium, it's in row 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So this would be 5s1, 5s2, 5p1, 5p2, 5p3, 5p4. And then again, this column, these will be 5p5 here for iodine, or 2p5 for fluorine, again because it's in the second row. And in the last column, these are called the noble gases, will end in P6. So let's do xenon. Ready? 1, 2, 3, 4, 5, fifth row, all the way over here. So it would be 5s1, 5s2, 5p1, 5p2, 5p3, 5p4, 5p5, and 5p6. And the noble gases are particularly important because they always have a filled energy level, or they have a filled S and P energy level for their top energy level. So for example, xenon, the highest energy level is going to be 5, and it's got a filled 5s and 5p orbital. So whenever you get that filled S and P orbital for your highest energy level, you know that it must be a noble gas or something that has an electron configuration like a noble gas. And this is going to become really important in the next video because it so happens that all of these configurations, again 3s2, 3p6, or 5s2, 5p6, 4s2, 4p6, are all extremely stable electron configurations. And that's why noble gases do not bond with other atoms, because they're already really stable in their configuration. And that's because of this filled top energy levels in S and P.